So I want to kick this week off by getting a little more formal about these objects that we've been creating and using as we are writing our code. Specifically, I want to talk about data structures and also data types. So let's start with data types. Now, when you get some data in R, you've read in some kind of data set that you're looking at, I want you to ask yourself, what type of variables does this data have? So for example, you might have numeric variables, right? You might have some kind of information that's being stored in number form. And now we want to keep track a little bit in R of whether these are integers, meaning whole numbers that you can count something with, or doubles, which means continuous values. Something like someone's height or weight would probably be a double. And sometimes your data comes in the form of words. So sometimes you have, for example, people's names or the street that they live on, something like that. We usually call these words characters or string type of data, but there's also a special type called factor that I want to talk about today as well. And then there's these objects, data types called Booleans or logicals, where you've often seen this in a data set possibly, where your values in your data say true or false. And they usually mean yes or no to a certain question. Does this person identify as male, true or false? Things like that. And there's all kinds of other data types in R. Today we're going to go over the main ones, but I want you to be aware that just about anyone can define a new data type. One that you'll see frequently, including next week, will be dates and times. Those are stored in a special way. You could see something where the data type is an image. There's a lot of different ways that we have unusual data, and then it comes with its own type. But you definitely need to start by being aware of these main ones, so let's start with the numeric types. So here you can see I've assigned the value of 5.5 to A, and we can use this function class to see the general data type, and we can see its class is of course numeric because it is a number. We can use this other function type of and get a little more specific, so that type of is telling us this is a double. This is not a whole number, it's 5.5, it's not an integer. And this str is a very useful function, stands for structure, and that one not only tells us that it's numeric, here abbreviated to num, but it also is reminding us of the value of that object A. And you can check if you have an object and you're kind of double checking what its type is currently. We can use is.numeric, and we can say, of course, yes, A is indeed numeric, thank you, R. And we can say, but is it a double? And yes, again, R says, you're welcome, it's a double. And so here I've got a very similar setup. I've stored the number 5 in the value of A, and I'm about to use this function is.integer. So I want you to ask yourself what you think will happen here. What do you think will show when I run this code? Now I've sort of set you up here, I'm sorry, but I'm not sorry. You probably said to yourself it's going to say true, because previously we had 5.5, which is not a whole number. Now we have 5, that is a whole number. So if I ask R, hello, is this an integer, it should say true. But unfortunately, or maybe fortunately, R doesn't think things are integers unless it's absolutely certain. And that's probably good, because you don't want a situation where you've got some data, maybe people's weights, that usually is reported in whole numbers, but really, philosophically, that's not a count. We're not counting up pounds. We're measuring a continuous value of weight, and we happen to round to the nearest whole number. So here A is not an integer because we have not super specifically told R, here comes an integer. The way that we would do that is with that highlighted L right there. It looks kind of funny. We say 5L, and that's telling R, I want 5, and I want the integer 5. And so now if we do is.integer, we see true, or we could check the type of A and see that it is an integer. Now in this class, and pretty much in most of your coding lives, I suspect, it won't be that important to make that distinction. It's not important that you use this L trick to make things integers. But you'll probably see it in other code, so I wanted you to be aware of what that lingering L is doing. It's being very precise that we want this integer of 5. So those are numeric data types. They're pretty straightforward. They work how you'd expect. The next data type I want to tell you about is Boolean. Boolean is kind of a general programming term. In R, the computer stores this as being called logical. Either name is okay. But for this type of data, Boolean data, you can only have true or false. And I really want you to think of this as being integers with values 0 or 1. And 0 means false, 1 means true. So here I've made an object called is5, and I'm checking to see if A is 5. Now that line of code might look a little weird, but I want you to remember what's going on with each symbol. So we're saying I made up the name is5, I'm using my assignment arrow, and what I'm storing in is5 is the results of checking whether a is equal to 5. So those results are going to be true or false, and in this case, of course, it's true. We can see that the class of this object is5 is logical, is a Boolean. And we can also say, look, R, I don't want you to treat this as a Boolean, I want you to treat this as an integer. So I can use this function as.integer, which says, please force this to be a different object type. And that works very naturally with Booleans. It's okay, R is not upset about this. It says, sure, here you go, this was true, and that's a 1. And in fact, this is so common to treat Booleans as integers 0 and 1, that you don't even have to do that coercion step ahead of time. So here at the bottom I've said, is 5 plus 1, and maybe it sounds a little weird, true plus 1, what does that even mean? But because we're thinking of this true as an integer, R is very happy to do 1 plus 1 and find 2. So you'll see these Booleans fairly often. Most often you won't read them in with a data set, you will probably create them yourself. You'll maybe take something like everyone's state that they come from. But if I had that for my class, I had everyone's home state, I might want to say California versus not California. Who are my in-state and my out-of-state students? And so I'd check to see where is that state value equal to California, and I'd get back a Boolean, true, California, or false, not California. I'm so sorry, those of you who are not from California. So those are our numeric types, and then Boolean, which is kind of fake numeric. But of course you see in data all the time these things that are words. So here I've named this variable my word. My word, it's a variable. Ah yes. I really had that T there. I didn't have it there for a prop, but I think this is a funny name, my word. Anyways, I digress. So I have chosen the word Kelly because, you know, it's the best word. And I've stored that character information, that text, in the object called my word. So that my word object now has the type character. And I really want to make a point that it doesn't matter how you as a human parse these character objects. So here I've got a sentence, hi, I'm Kelly, and you and I can see that this has commas and spaces and an exclamation point. And so you and I might think of this as 3 separate words instead of just 1. But R doesn't care. R is like, here is an object, and what does that object contain? It contains text, it contains characters. And so these 2 objects here, my word and my sentence, they're both of this character class. And I should mention that you'll often hear in programming, and I'll probably use it quite a bit, these character objects, we sometimes call them strings. That's just a common parlance. Now, we have this next text type called factors. And I want to kind of show you what this looks like before I explain it. So here I've got the first few rows of a data set, and this data set involves different penguins of different species and some biographical information about the penguins. And if you look at that species variable, or at the very end, the variable sex, you can see that these are words, right? These ones have text rather than numbers. And so you'd think that they were of the type character. But instead of character, what you're seeing that column labeled as is FCT, or factor. So I want you to ask yourself for a moment here, perhaps you could even pause, what do you think is the difference between a character object and a factor object? So what's going on here is factors are when you have what is really a categorical variable. It's not just any string at all, it's not just any characters at all that could be stored. It's not like names where I might be Kelly and someone else might be Kelly spelled differently, and really they're not categories. And so in this case, if we're looking at species of penguins, there's actually only 3 species in this data set. Those strings are restricted to being one of 3 different possible values. And so if we look at the class, it is again factor class, that object, that species variable within the dataset penguins. And when you have a factor object, if you want to see what those possible categories are, you can use this levels function right there. So here we've got our Adelie, our chinstrap, and our Gentoo penguins. Those are the 3 species. And remember that structure function, str, often very, very useful. Here we can see it is a factor, it has 3 levels. It starts to list the variable or the levels, but it runs out of space, so don't take that too seriously. Always use levels to see all of them. And then you see this 1, 1, 1, 1, 1. Get to that in a moment. So factors are kind of weird. Now it makes sense that you could go from a factor to a character. So here what I've done is I've taken that species variable and I've said instead of a factor, please make it a character. I force you to treat this as an ordinary character. And R is fine with that. They're still just words, and here we have the words. The first over 100 penguins are of Adelie species, and if we could see the whole data set, we'd see the other types as well. But here's what's weird about factors, and this is actually something that has ruined some of the best science out there. People make this mistake all the time. We can say, please be an integer. And you'd think that would break. It kind of made sense for R to be able to take trues and falses and turn them into zeros and ones, but it doesn't super make sense that R should be able to take words and turn them into numbers. But here, it's doing exactly that. What it's doing is saying, well, those Adelie penguins, we'll call that category 1. That's factor level 1. And then the chinstrap penguins, for whatever reason, those are factor level 3. And then the Gen 2 penguins are factor level 2 at the end there. And so actually, the factor to integer conversion happens very naturally, and it happens without any warnings from R. R is perfectly happy to do this. But you have to be careful, because that's really different, right? Right now, the information you're seeing on the screen doesn't really tell you about these species. So we're going to spend some time next week on factors. That is a kind of very tricky variable type that is really common in your lives. But for now, as we're just thinking about identifying types, I want you to be aware of that weirdness. All right, so those were our main object types. We had the 2 numeric types, and then we had the 2 word types of data, and then we had our Booleans. So now I want to talk about structures. So getting away from type, what is stored in this data, to how is this data stored. The structures that you want to know, well, your object that you've created in R, it could be a function. More importantly, it could be a vector, list, data frame, or matrix. I hear a lot of people, and I make this mistake too, refer to things as lists, because in English, in our human brains, we're like, oh, it's just a bunch of values together, that's a list. I'm going to start being nitpicky and forcing you away from using that word, because these are very different structures within R. So vectors, a vector is a set of values, somehow concatenated together, and it's important that these values all have to be the same type. So what we see here, I've made my vector, and I've sorted it very helpfully, ABC, and if we look at the structure of that object, it tells us a few things. The first thing it tells us is that CHR for character. It says the data types in this vector are character data types. And then it says that 1 to 3, that's telling you that there's 3 elements in the vector. And then it's shown you the 3 elements right there. So if you look at the structure of an object and it tells you a data type and a length, that's telling you this is a vector, and it's specifically a vector of a certain type. And so in this next one we have a numeric vector, and it looks almost the same, but then when you look at the structure you see the class numeric, and then the 1, 2, 3. And so because these have to be the same type, if you try to mix and match types, R is going to sort of cheat. It's going to throw up its hands and say, look, you surely made a mistake because you cannot mix and match. So here I've tried to make a vector with the number 1 and the letter A. And now R is very helpful. Instead of saying, I can't do it, it often tries to do its best. And so what you can see it's done here is it's decided, well, I know how to convert the number 1 to a string. It's just the character of 1. But I don't know how to convert A to a number. So what I'm going to do is I'm just going to pretend that you intended for this whole vector to be strings, and now I have a character vector. We've dealt with objects already that only contain one piece of information. Here this is a very exciting vector, myvec, which contains the information of just the number 1. We sometimes call these atomic vectors, like it's the smallest possible atom for a vector with 1 element. But really, these are just vectors. Everything in R is a vector of length 1, or every basic item in R is a vector of length 1. And we can see that because if we look at the structure here, it says, well, look, it's numeric. And if we look at the first element of this vector, it is that value 1. This is no different from a vector of more values. It's just only got the 1 element. So vectors are your simplest data type. And then if you kind of imagine a two-dimensional vector, that's all that a matrix is. So a matrix also requires everything to be the same type. And instead of just being one vector, it's now 2 dimensions, rows and columns. So here you can see I've made a matrix with some even more exciting letters. We got all the way up to D this time. And I've decided I want 2 rows and 2 columns. So I'm kind of thinking of this as I've got this vector, A, B, C, D, and now I've decided to disperse it into rows and columns so it looks like a matrix. And so when you look at the structure, it looks almost exactly the same. The only difference is when we look at that length, so we've got our character is our data type, and then it says, well, here we've got 2 rows and 2 columns. So you can see that that's 2-dimensional. And be a little careful. So here's what this object actually looks like. If you are going to take that long vector and kind of warp it up into a nice matrix, just be a little careful with those, with those rows and columns, because you can see here it filled in A, B, C, D. So oftentimes if you are creating matrices, it's really good to double check and make sure that you disperse your data in the direction that you wanted to. But regardless, vectors, matrices essentially behave identically for all intents and purposes. It's just a question of whether there's just one set of data or whether there is a 2-dimensional situation. And so what are lists actually? A list is a super general object. Really, anything at all that you want to put into a list can be put into that list. So here I've made a very goofy list. My first element of the list is the string, well, hi there. My second element is the numbers 1 to 10. And my third element, I've taken that matrix from the last round and shoved it into this list. So if I look at this list, I can see first element, which I've titled A, is a string, second element is a vector, third element is a matrix. And that's okay. You can mix and match as much as your little heart desires when you're using lists. If we look at the structure, and this is actually where I use this str the most, it says, here you go, this is a list of 3. We can see that first one is an atomic vector. It's a character object. Second one is a vector of length 10, which is integer type. And the third one is a matrix with 2 rows and 2 columns of character type. And so I can access those elements, and in fact this $sign should look familiar. It's a way of accessing things in a data set. And I can say my list, $A, and get back just that one string right there, well, hi there. Now there's another way to access information in the list, and that's with those square brackets, much like you do with vectors or matrices if you want to. And so I can see here, I've done this in 2 separate ways. This first line I've used 2 square brackets, and the second line I've only used 1. And in both of them I've asked for the second element of the list, which as we saw was a vector of the numbers 1 to 10. So I want to ask yourself, what is happening that's different between these 2 lines of code? Surely you can see that the output is slightly different, but I want you to ask yourself what that implies. What is different about the objects that are being output in each of these 2 lines of code? Maybe you paused and thought about it, maybe you didn't, that's okay. Here's the answer. So if we look at the structure of that first one, the one with the double brackets, this is a good chance to practice what you've just learned. What type of object have we got here based on the output of that structure function? What I'm seeing is the data type is integer, and I'm seeing that this is a vector of length 10. What about when I only had 1 set of brackets? What type of data, or what type of structure did I output? That one is outputting a list. It's a list of length 1. The one element in the list, named B, is a vector of length 10. So in the first case, you actually yanked that vector right out of the list, and you said, just give me back the vector. I don't care that it came from a list. I want it by itself. That's what the double brackets means. And the single brackets means, look, I still want to keep this list structure. I still want this to be a list. I still want that element of the list to have its original name, which was B. But I want you to only give me back a list with just the one element that I asked for. So this is kind of your first sneak preview of something that we'll talk about a little more later in this material, which is that I want you to think very carefully about what object is output from your lines of code. When I ran this line of code, what did I get back? Was it a list Was it a vector? Was it a matrix? Was it of type integer, double, Boolean, factor, etc.? This will help keep you from making mistakes that are a little hard to track down. So let's take this moment to briefly check in on that information, and we will come back with some more details.